Hey guys, this is Mrs. Sharon Berg, and this is our lecture over Simplifying Radicals 13.2. Um, this one, just note on this lesson, you're not going to be using your calculators. You're not going to be um, really getting it down to a decimal. You're actually going to be simplifying. So I need to teach you a few things first. Over here, some properties of square roots. I kind of already shared this one with you on the last page, but if you have a square root of a number, a square root of a fraction, you can break that down into the square root of the top and the square root of the bottom. Okay, so if I had some real numbers in here, let's say it was the square root of 4/9. That can be the square root of 4 over the square root of 9, which is 2/3. Okay, this next one, if you have the square root of, say, a number, let's say it's 8. Okay, now that's not a perfect square. 8 is not a perfect square. But I could rewrite 8 into two factors, 4 times 2. And I could take, and then you can split this up further. You could think of it this way. Okay. And so I can take the square root of 4, which is 2. So then I have 2 times the square root of 2. So final answer, 2 square root 2. Okay. That's another property of square roots. Now, when you're starting to talk about the square root of a variable, let's say it's y to the 4th. To find the square root of an expression with even exponents, okay, that's even, you're going to divide the exponent by 2. Okay, so they're asking for the square root of that. The square root of y to the 4th, take 4 divided by 2. The answer is y squared. And if you think about it, y squared times y squared is y to the 4th. Okay, so that should make sense. But this rule is really helpful. Let's say you were going to take the square root of y to the 40th power. Again, it's understood that that's a 2. So if I applied that principle again, I simply, and the expression underneath the radical sign, 40, take 40 divided by 2. Dude, it's pretty easy. It's y to the 20th power. Okay. This also applies, let's say you want to take the cubed root this time of y to the 15th power. If you take that 15 and divide it by 3, that's going to be your answer, y to the 5th power. And again, if you think about it, y to the 5th times y to the 5th times y to the 5th, adding the exponents, you do get y to the 15th. So I kind of thrust that upon you just to help you start thinking about it. But we'll apply those concepts in these problems. So when you're doing your Hawks homework, the simplest form for square roots is when the radicand has no perfect squares left as a factor. So the number underneath the radical sign, you can rewrite that number as the product of two numbers, but you got to find all the perfect squares and take the square root of them. You'll see what I mean in a minute. Really the same thing for cube root, but when no perfect cubed is a factor. Okay, simplify each of the numerical expressions. Well, 48 is not a perfect square, so you kind of start thinking to yourself, gee, let's see, let me think of factors when multiplied together get 48, and maybe there's a pair of factors here that might have a perfect square in it. And you start writing out all these factors. This one has a perfect square in it, doesn't it? This is also a pair of factors that has a perfect square. So I'm going to go with this one. And the reason why you could do this one, it would just take you an extra step, because in this 12 here, you could rewrite it as 4 times 3. Okay, probably confusing you a bit at this point, so let's just keep going. I am going to rewrite 48 as 16 times 3. Okay, now I can take the square root of 16, and when I take the square root of 16, and if it helps, you can rewrite it one step further. Okay, So when I take the square root of 16, that is 4. And I'm going to leave my answer as 4 square root 3. And I'm done because this 3, there's no way I could write 3 as the product of a perfect square. We're done. Square root of 63. I'm going to rewrite that 63 as 9 times 7. Okay. Then I can rewrite this a step further, kind of break it apart. Square root of 9 is 3, and then I have the square root of 7. The next one. I am first going to rewrite this as 2 separate square root problems. The one on the bottom is easy. Square root of 16 is going to be 4. Now, how can I rewrite the square root of 75? Is there a way I could rewrite that as a product of 2 numbers where one of them is a perfect square? And if you were thinking 25 times 3, that's great. Then on my final answer, I could take the square root of 25 and a 5 would come out, right? Leaving the square root of 3 and then 4. That's my answer for Hawks. Okay, now we're getting into some with expressions that have a variable. Can I take the square root of 16? Yes, a 4 would come out. And again, the Hawks might show you that you can write this as 2 separate factors, and then square root of 16 is 4, square root of y squared is y. Sometimes I like to do it all under the radical sign. I'll show you what I mean. First of all, I'm going to rewrite 72 as the square root of 9 times 8, and then we also have a squared. I can take the square root of 9 and out comes a 3. And then I can also take a squared and out comes an a. Underneath the radical, I still have an 8. This is an example where I am not simplified yet. When I rewrote 72, I could have written it a little differently. But now, let me show you what happens here. I'm going to rewrite 8 as 4 times 2. Now, when I take the square root of 4, a 2 will come out. And I'm going to need to multiply that 2 that comes out times what's out there, okay? So a 2 is coming out. There's already a 3a out there. So 3a times 2 becomes 6a. And then what is left underneath the radical sign is the 2. Okay, that was just an example of, it's okay if you don't find the largest perfect square at the very beginning. You're just going to have an extra step. And that's okay. You're still going to get the correct answer. All right, let's rewrite 12. Let's rewrite that as 4 times 3 times x squared times y squared. Can I take the square root of 4? Yes. So a 2 will come out. Can I take the square root of 3? No. Can I take the square root of x squared? Yes. An x will come out. Can I take the square root of y squared? Yes. A y will come out. What's left underneath the radical sign? A 3. Okay, are you getting the hang of it? All right, square root of 81, x to the 4th power. Yes, I can take the square root of 81, happens to be a 9. And what did I tell you to do this? This is understood as a 2. We simply take this 4 and divide by the index, and so that becomes x squared. So we took the square root of 81, and we took the square root of x to the 4. So 9x squared is the answer. Okay, look what I am going to do here. I am going to rewrite this as 64 times x to the 4th times x to the 1 times y to the 1. Let's see if I can explain to you why. Now, I could not take x to the 5th, I couldn't take the square root of it because 5 is not divisible by 2 evenly. But look how I chose to rewrite x to the 5th. X to the 4th times x to the 1 is x to the 5th, isn't it? So I haven't messed with the integrity of the problem here. But now when I take the square root of it, you'll see what happens. Also, I tack on the y to the 1 power here. it's the y, it's understood, but sometimes it helps to see that. Okay, so let's apply, or let's take the square root of whatever we can underneath the radical. Can we take the square root of 64? Yes, 8 comes out. Can we take the square root of x to the 4th? Yes. X squared comes out because 4 divided by 2. Can we take the square root of x to the 1? No. Can we take the square root of y to the 1? No. So we're going to leave x and y underneath the radical sign. Okay, let's try another one of those. This is again square root. If it doesn't say, you can assume it's a 2. Let's rewrite 18 as 9 times 2 times a to the 4th times b to the 6th. Okay, can we take the square root of 9? Yes. 3 comes out. Can we take the square root of 2? No. Can we take the square root of a to the 4th? Yes. That would be a squared. Can we take the square root of b to the 6th? Yes. 6 divided by 2 is 3. What's left under the radical sign? A 2. That's the answer. A couple more of these. They're getting a little more challenging. All right. 9a to the 13th power divided by b to the 4th. First of all, we're going to make this into 2 separate problems. 9, and I'm going to make this into a to the 12th times a to the 1, and this over the square root of b to the 4th. Okay, so you might be wondering, why did I rewrite a to the 13th as a to the 12th times a to the 1? Well, you want to take the 13 is odd and not divisible by the index here, which is 2. So you want to go with the next one down. So then you ask yourself, is 12 divisible by 2? And it is. And so from here, let's just apply the square root, top and bottom. The square root of 9 is 3. The square root of a to the 12th, that's 12 divided by 2, is a to the 6th. And a to the 1, or just a, is going to stay underneath the radical sign. Then on the bottom of this, the square root of b to the 4th is b squared. And that's the answer. Okay, this is our very first cube root. This is our very first cube root. This is where it gets challenging, at least it does in my brain. You really have to start thinking of, instead of squares, just when you think you have those down, you have to think in terms of cube. So now we're going to have to rewrite 54 as the product of a number and another number, and you're looking for a perfect cube number, which is why it's really helpful to study what those perfect cube numbers are. And the other boo-boo I tend to make on these is I forget. I can't tell you how many times I do the work and I do it right and I put this answer into HOX and I forget to put the 3 here. Very frustrating. Anyway, I'm rewriting 54 as 27 times 2. 27 is a perfect cube. 3 times 3 times 3. And I'm going to leave x to the 6th as it is because 6 is divisible by 3. So now let's take the cube root of what's underneath this radical sign. The cube root of 27 is 3. Cannot do the cube root of 2, so that's going to stay underneath the radical. We can take the cube root of x to the 6th because we're going to take the 6th and divide by 3, and that's 2. So when we take the cube root of x to the 6th, out comes x to the 2 power. And underneath the radical sign is the 2. Okay? Okay, cube root. Ooh, this time we have a negative 40 x to the 4th, y to the 13th. Well, don't be too afraid with this negative, because since it is a 3, that's going to be possible to take the cube root of a negative. But watch how I rewrite this. I have to rewrite negative 40 into the product of something that's perfect cube. Well, I'm going to use negative 8 times 5, first of all. Now, I use you have to put the negative with the one that you're going to take the cube root of, just a little rule, okay? X to the 4th, I'm not going to leave that as x to the 4th. 4 is not divisible by 3, okay? So I'm going to go down 1. Is 3 divisible by 3? Yes, it is. So I'm going to have an x to the 3 here, and then don't forget, you have to include your x to the 1 to get back to x to the 4th. And then finally, a y to the 13th, that's not going to stay y to the 13th. 13th is not divisible by 3. we're going to rewrite that as y to the 12th. 12 is divisible by 3, y to the 1. Okay, now for the fun part, I think. We're going to take the cube root of whatever we can, and whatever we cannot needs to stay underneath the radical sign. Okay, cube root of negative 8 is negative 2. Can we take the cube root of 5? No. Can we take the cube root of x to the third power? Yes. 3 divided by 3 is 1, so that's just going to be an x coming out. X to the 1 power needs to stay. Can we take the cube root of y to the 12th? Yes. 12 divided by 3 is 4. So y to the 4th comes out. And can we take the cube root of y to the 1 power? No. So that one will stay as well. So underneath the radical, we have x to the 1, y to the, and the 5. 5, x to the 1, y. Now, what did I do wrong? Everything's good, perfect, except one thing. Don't forget to put your index in there. I tell you what, I do that on Hawks. I get so frustrated. 2xy to the 4th times the cube root of 5xy is the answer. Okay, last one. Cube root of 250, 88 b to the 11th. If you can do this one, you have arrived. Okay, let's rewrite this cube root. Let me help you out a little bit. 250 is looking kind of like ominous, like how could we ever figure out if this is a product of something, that it's a perfect cube? Well, I'm thinking 125. I know 125 is a perfect cube because it's 5 times 5 times 5. So I'm going to rewrite 250 as 125 times 2. Now, I need to rewrite my 8. 8's not divisible by 3, so I can't use a to the 8th. So I'm going to ask myself, can I use a to the 7? Is 7 divisible by 3? No. Well, I'm going to go down another one. A to the 6th. Is 6 divisible by 3? Yes. So I will do a to the 6th, but look what I have to tack on. I have to tack on a to the 2nd power, because this could get me back to a to the 8th. 6 and 2, adding that together. Now, same thing with b to the 11th. Can I use the 11? No. Can I use 10? No. Can I use 9? Yes. So I'm going to go b to the 9th, but then I'm going to have to also have b to the 2nd power. Now I'm ready for my hopefully final step here. We're going to take the cube root of everything here. Okay. Can we take the cube root of 125? Yes, it's 5. Can we take the cube root of 2? No. That'll stay underneath the radical sign. Can we take the cube root of a to the 6th? Yes. Out comes 6 divided by 3. Can we take the cube root? No. Can we take the cube root of b to the 9th? Yes. Out comes b to the 3rd power. And then this b squared is going to have to stay. So then I'm going to do the cube root of 2a squared b squared. And that is the answer. Guys, that's the end of this lesson. I hope this helps you. Good luck. Let me know if you have any questions.